Okay, let's take a look at question 18 in topic set 10. This is an organic chemistry question. It's giving us an organic compound called mimosine, and it's asking us a few questions related to that compound. The picture I have here is a little hard to see, so I decided to get another copy of the molecule and put it down here so we can better look at all the information. So the first question is just functional groups. So let's take a look at the functional groups that we have. The one functional group we have is this one right here, which is alcohol. We also have this functional group, which is called ketone. That's just a carbon double bonded to an oxygen. We have this, which is similar to this, and both of those correspond to an amine functional group. And then we have this right here, which is a COOH group, and that is what we call carboxylic acid. Okay? Let's take a look at the second question, which is the hybridization question. So what we have to know is we have to answer a question about what type of hybrid orbital is used by the carbons. Well, in order to get that information, you have to count the number of effective pairs for each of the carbon. To help you with that, I'm going to draw a couple of additional things that's not present right here. So remember that each of these carbon actually has a hydrogen attached to it. They're just not drawn in this line structure drawing. So I'm going to add those to help us visualize the hybrid orbitals. This one would have 2 hydrogen, and then this carbon right here would have another hydrogen, and this carbon in the double bond would not have any hydrogen attached. Let's now take a look at the type of hybrid orbital we have. So for example, if we look at this carbon right here, we have 3 effective pairs of electron. So that means that that's going to be an sp2 carbon, right? If you look at this carbon right here, you also have 3, 1, 2, and 3. So that's also sp2. In fact, if you go around this ring, all of these are sp2 carbon. Okay? Now let's move on out of the ring into the other carbons. If you look at this carbon right here, it has 4 bonds or 4 pairs of electron. 1, 2, 3, and 4. So if it has 4, that means that this carbon is going to be an sp3 carbon. If you look at this carbon right next to it, it also has 4 bonds. 1, 2, 3, and 4. So that carbon is also sp3. And then the last carbon we have, this one right here, is an sp2 because we have 3 effective pairs. Okay, so basically we have all of the carbons being sp2 except for the 2 right here. 1 here and then 1 here. Okay, now let me erase this so we can answer the last question, which is about sigma and pi bonds. Okay, so the question is how many sigma and pi bonds are found in the molecule. To count sigma bonds, remember that sigma bonds is all the single bonds plus the first bond in a double bond or a triple bond, right? So let's count that. So we have 1 single bond right here. That's 1, 2, 1 of these, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 2 hydrogens attached here. 20, 21, 22, 23. And don't forget that this carbon also has a 4th bond going to a hydrogen, so that would be the 24th sigma bond. 24 sigma bonds total. And if we look at pi bonds, those are the only ones with double bonds. The second bond in there is going to be a pi bond. So 1 here, 2, 3, and 4. 4 pi bonds.